How to choose the best power supply for your system. 80 plus gold, 80 plus bronze, 500 watts, 1200 watts. It can definitely be hard to pick out a power supply when building a new PC. Luckily for you out there, I've already done most of the thinking for you. So sit back and find out how you can pick the best, most efficient power supply for your PC here on East Coast Tech. The efficiency of an energy producing object, be it a light bulb, nuclear reactor, or a power supply, is defined as how much energy it produces versus how much waste energy it gives off. Light bulbs are pretty good at lighting up your room, but you probably won't be heating up your room during the winter with it. LED light bulbs are considered highly efficient as the heat they give off is minute in comparison to the light they deliver, as well as being cost effective. Cost effectiveness is another way of measuring efficiency. If it costs $1,000 a year to light your home with an incandescent bulb, but only takes $100 to light it with LED bulbs, the LED bulbs will be considered more cost effective and subsequently more efficient. Take note here that although this is mostly the case, it doesn't work like that every time. Like with heating your home. Oil could be more efficient at heating your home during a cold winter, but could cost you more than, let's say, natural gas, to the point where although you would be using more natural gas to heat your home than you would oil, it would still be more cost effective to go with natural gas. Luckily, power supplies operate more like light bulbs, in that they deliver electricity to something, and our waste energy is heat. Hence, the built-in fans. Modern power supplies take in AC electricity from the wall and convert it to DC for use in computer electronics. How much power they can deliver is noted in watts, which is usually marked on the power supply itself. My PC, for example, has a 750 watt power supply, so in theory, it could deliver a maximum of 750 watts of electricity to my components, although you wouldn't want to do that. That's where the efficiency rating comes into place. In addition to the wattage of a power supply, they are also usually rated with an 80 plus something, bronze, gold, platinum, etc. The basic 80 plus rating means that the PSU is rated for at least 80% efficiency at 20% load, 50% load, and 100% load. The 80 plus bronze means that the PSU is rated for at least 82% efficiency at 20% load, 85 at 50, and 82 at 100. 80 plus silver, which isn't really used anymore, means that the PSU is rated for at least 85% efficiency at 20%, 88 at 50, 85 at 100. For gold, and you can kind of see the pattern here, it's rated for at least 87% efficiency at 20, 90 at 50, and 87 at 100. From what I can tell by the data so far, a power supply of any rating is going to be most effective at around 50% load. So the parts you pick will in turn suggest by themselves what kind of power supply you should be buying. Using my PC as an example again, PCPartPicker.com says I have a total maximum power draw of 395 watts. The power supply I'm using is a Roswell Photon 750 watt power supply, which is perfect since half of 750 is 375. So 395 is still within range for optimal efficiency. And since my power supply has a gold rating, it'll operate at 90% efficiency most of the time. Ironically, it'll be more efficient as I put it under more load, as opposed to leaving it idle, since that 395 max power draw is a suggested maximum. PC Part Picker is a great tool here since it keeps track of fine spec details like power consumption. It'll even filter out parts that are incompatible with what you're currently building, so it'll throw out weaker power supplies as you search for them. Pretty neat, right? To recap, choosing a power supply should be done last, since you don't know what kind of power you're going to need to provide if you haven't figured out what you're putting in your system. Also, you should not skimp on the power supply when you're formulating your budget. It may not be as fancy as a motherboard, but considering it's the backbone for your entire rig, it kind of makes sense to buy a power supply from a reputable brand, and with an 80 plus rating. As for the rating, get the best you can afford. Most people will find that bronze power supplies to be a fair middle ground, but if a gold power supply comes within range, I suggest you go for that. Another thing to look at is fully modular versus semi and non-modular power supplies. Modularity on a power supply is basically whether or not the cables can be removed or replaced from the power supply unit. My Roswell Photon is fully modular, so I only have to plug in the necessary cables for my PC's needs. So it helps a lot with cable clutter. Semi-modular power supplies usually hardwire the mandatory cables like 24 and 8 pin for your motherboard and CPU respectively, and for non-modular power supplies, you guessed it, all of the cables are hardwired in, and to make matters more hilarious, they are usually ugly ketchup and mustard cables. Again, this comes down to needs and budget. Ultimately, modular versus non-modular doesn't affect the performance of similarly spec'd power supplies. On to my personal power supply buying checklist. 1. Determine total power draw, which is easily done on PC Part Picker. 2. Pick a power supply with a watt rating roughly double the total power draw of the system. 3. From the budget, pick the best efficiency rating I can afford. 4. Try to go for semi-modular or modular, if your budget allows. Hopefully, this can set your mind at ease when deciding on your next power supply. Thanks for watching, guys. If you like this video, hit that like button, get subscribed if you want to see more content from me. I'll link a few power supplies at different price points in the description to give you guys a place to start. This was Andrew with East Coast Tech, and I'll see you next time.